Traditional ventilators require either intubation or a mask in order to provide ventilatory support. The NMV is unique in the sense that it does not, but in order to accomplish this, it involves having surgery. There are two components to the NMV. Component 1 is an end-tidal CO2 monitor that doubles as a transmitter. It is ring-shaped and surgically implanted in the trachea. Component 2 is an artificial vertebrae that doubles as a receiver for Component 1 and as a phrenic pacer. Component 1. In order to get an accurate end-tidal CO2 reading, it must be able to measure all the air that the patient exhales. Traditional capnography uses a round tube that all the air must pass through, hence why this is in the shape of a ring, as you can see here in blue. Because food would make the end-tidal CO2 monitor less accurate, it needs to be installed into the trachea rather than in the esophagus or in a superior anatomical structure. It is also surgically implanted just below the vocal cords so that there is no interference with those either. As the air passes through the ring, it will measure the end-tidal CO2 and transmit it to Component 2. While some implants, like IUDs, are small and not that invasive, the complexity of Component 2 necessitates it being larger in size and therefore much more invasive. To minimize how invasive it is, we are replacing an already existing structure with an artificial C6 vertebrae that doubles as a receiver and as a phrenic pacer. Because the phrenic nerve branches off the spine between C3 through C5, we place this vertebrae immediately below, hence its location is at C6. It attaches to both the left and right branches of the phrenic nerve and will electrically stimulate the nerves with an electrical impulse great enough to generate a muscle contraction of the diaphragm. Let me put it in more simple terms. You breathe out and Component 1 measures the EtCO2 and transmits it to Component 2. Component 2 processes the info and stimulates the phrenic nerve accordingly. When it does this, there are either three options. Either the last breath you took was too small, too big, or just right. If the last breath was too small, then the goal of the following breath is to help you off-gas and blow off that extra CO2. So, in order to accomplish this, the next breath that the machine will deliver a greater electrical impulse than the previous breath, thus increasing the strength of contraction of the diaphragm, inducing a greater subatmospheric pressure, thereby increasing the tidal volume and maintaining adequate ventilation. If the previous breath was too big, then the machine simply does the opposite. If the machine measures the previous breath as being just right, then it simply repeats what it just did.